Okay, Assalamu alaikum, mashallah. Welcome back to the class. I wish you had a good weekend. Today we are going to start the discussion on the stiffness of the member. And if you recall, what we did last class was this. We basically, I am not going to again, unfortunately. I know lecture is going to be lengthy and I need you to focus on it. I can tell you, ya akhwan, this is the stiffness of the bolt. This is KB. Now, what I told you is that we are going to study KM, okay?
Yes.
And with that, any joint, yes? Okay. Just give me a second. Okay, we are back. We're back. Hopefully we're gonna be good. Okay, now, so what I was saying in the beginning, that we taught you how to find KB, and today we are gonna teach you how to find KM and KB and KM. Faisal, still, do you need anything? If you don't, please lower your hand. So what is the purpose? Let me jump quickly, okay? Let me jump quickly to this slide over here. Do you see this? This slide shows you how are we going to study the strength. And if you look, there is a constant which is called C. This C, ya shabab, is actually KB divided by KB plus KM. Now, what is this constant? It determines how much load goes to the member, how much load goes to the bolt. And later, when we move on, you will see that we are going to find, look, you see this? This is a factor of safety. And over there, C is there. This is C, which is KB over KB plus KM. And we will continue over there. Look, there is another factor, and there is C again. So all of the story that we will have here is going to help us find this constant C, which will later be used to analyze the health of the joint, the entire joint. I know you don't know what is what were the N and 0 and L. That doesn't matter. Okay, you will see later. Of course, we'll also talk about fatigue, and you will see that in fatigue we will have C again coming up. So now, what is KM? Let me tell you this. If I explain this in too much details, it will burn the entire lecture. In the exam, final exam, I don't think there is any chance you will have a final exam and you will not need to find KM. There is no chance. هذا لما أقول يا شباب أنا ما أعتبر نفسي قاعد أغششكم. There is no chance. No chance. No way. There will be no final exam if there is no calculation for KM and KB. No final exam. So let's try to explain this very well. Try to solve a problem today because we need to move on If you have any question, you can always stop me. Okay? First of all, what you need to understand is this, that if you put a joint, two blades, let's say one of them is red, one of them is green, and then you brought up the bolt in here, okay? And then you put the bolt is black, it has a head, let's say there is a washer, the bolt is going here, we told you the nut will go this way, and there is an extra two thread, as I told you. We're gonna talk about this later, more and more. Now, and then we clamp them. So this is hexagonal nut, okay? And now we clamp them. So this is under compression, all right? And the bolt is under tension, as we explained. We want to know, ya shabab, if I have a flange like this, which we talked about before, and we told you, you will see this a lot when you get to the industry, inshallah. They put too many bolts. Sometimes, ya shabab, too many, such that you barely have a spacing. Barely, يعني, side by side. You barely put the socket and then screw. Just a little gap. Why? Why not 4? Why not, like the car, we have 5? Why? Well, some of you will tell me, because the load is too much and we need to take, when we put too many bolts, we distribute the load over the number of bolts, which is accurate. There's no doubt about it. But there is another story. That story is because, ya shabab, if we imagine, let me clean this very quickly. If we imagine that there is one bolt here, one bolt here, one bolt here, one bolt here, I want you to think that there is a field, like a compression field, a pressure field generated around the bolt. This field goes like this. And then there is another one like this. Then there is another one like this. Then there is another one like this. Now the question is, what is happening here? Well, sadly enough, this part doesn't have the propagation of the clamping force around the bolt, will not permeate, ya shabab, will not spread all over the earth. It will have a physical, small, confined space. And for that reason, what will happen? If you have a fluid, gas, whatever, it will leak from here. So what should we do? You clamp more. If you clamp more, maybe this green region will expand, but it will not be enough. Remember one thing, ya shabab, do you know that if you go to your car today tire, and then if you keep clamping the bolt, حق التاير يا شباب, do you know what will happen? You keep clamping. You bring 2 guys, and then they stand up on top of the, the clamping wrench, and then you push down just to clamp more. What will happen at the end? Does anybody here knows what will happen? Keep clamping. Keep. Don't stop. It is too tight, but you increase the torque and you keep clamping. What will happen? Ha, shabab? Anyone? You can't keep clamping forever, ya shabab. Something is going to happen. Something bad is going to happen. What is it?
If you keep clamping, maybe it would break.
Break what? What is going to break?
The member itself.
The member? What if the member is too hard?
Well, the clamp would break.
What is the clamp?
The thing that we put the clamping force in.
You mean the bolt?
Yes.
Yes, the bolt, the screw. we call it a screw. A screw يا شباب, as you clamp more, it stretch more. It's like a tensile test. You can stretch it until one moment it will break. So what do? We can't just keep clamping. Although clamping might increase the green area a little bit more, but it will not. The bolt will break. So alternatively, what we can do is this. We can, يا شباب, put more bolts, and there you go. The green now overlap. You don't have to clamp the bolt until they break, and your joint is safe. You have the green region surrounding the circumference. No fluid will go out. The fluid cannot go out. It will get stuck here, right? It will get stuck there. خلاص. معناها you are basically sealed. Now, when we talked about this green region, I want to tell you that experimentally, it was found that this region, look يا شباب, this is very important, okay? Imagine that we have one plate here and another plate here, and they are not the same in thickness, okay? And then, as usual, we drill a hole and we put the bolt. طبعا, let's assume that there is a washer down. Let's assume that there is another washer down. By the way, you need to understand the idea of the symmetry. We don't put small washer down, big washer up, and one not big. No. Everything is symmetric. Even the head of the bolt and the nut, they are exactly the same size. المهزلة اللي نشوفها هنا في around us, people just put things together. It doesn't happen in the industry. Okay? Now, what will happen is this. When we put the bolt over there, this is the head of the bolt. The nut will be exactly the same width. They will be parallel like this. This end and this end, parallel to each other. Sorry, ya shabab, it's supposed to be like this. Okay, now we clamp them, all right? So we clamp them. طبعا يا شباب, the bolt is in here like this. So let me show it to you. And let's say this is the extra thread in the back. Now, let me just make it a little bit colorful here. This is the nut. Okay, this is the nut, the head. Okay, the washer is here with a gray. Okay, the bolt is blue. There it is. And the members are on the side white. Now, what happens is here, ya shabab, just to be perfect. When you clamp that green region, do you know how this is going to look like? I'm going to show it to you. First of all, physics. What will happen? You go, where are the faces that do the clamping? This face and this face. They will start clamping together, and then they will think that, what is this distance? How much is this distance? Let's say this distance is capital A, okay? If this distance is A, then actually I don't want to make it capital A. There is a letter A, we will use it. Let me call it Y, okay? So what are they going to do? They will go to Y over 2. لاحظوا, Y over 2 may not be coincident with the line where the two plates, made together. No, it doesn't matter. Just take Y over 2 and then draw a line. This is what the two clams are doing now, the head and the knot. This is what they are thinking. And then what are they going to do? They would say, look carefully, Shabab. They would say, take this point, take this point. These are the point at the end of the head. And then the other 2 points, which are red, at the bottom of the knot. These 2 points are parallel. You know, the 4 point, 2 point up, 2 point down. Then look what will happen with a certain angle, which was agreed upon experimentally. It was estimated to be nearly 30 degrees. Okay? The wave of the clamping wave, call it a wave, call it a brusher. The brusher will expand like this with an angle 30. 30 from where? From here. This is 30. The bottom one will go angle 30 as well. So what are they going to agree? They are going to meet because the same angle and the distance is just at the middle. They will meet here. And then there is another one here and another one there. And they will meet exactly at y/2. Now, this new green line will be very important. Now, you might be lucky to have this green line at the middle of the joint like this. If the two thicknesses are the same, then this is going to be like this. If you imagine, it's going to be like this. So the green line will be just in there. But here, it is not. Now, why this is very important? Why? It turns out that if you imagine that this is, although this is not the real life, that this is going to continue up and this one is going to continue down. And then take the bottom part, this one, look, I'm drawing the green line, and then the red one like this. This is what? This is a cone. A cone. Cone, ya shabab. Cone. You remember it from math? Now, but in reality, the pressure start to be applied at here, right? Those dots at the top, they are not there. So this is the first dot, this is the second dot, and this is the line. So what I'm going to do, I will clean this up. Now, do you know what mathematically, what do we call this? A cone without the apex, you know, the tip, it's been cut. If we cut the top part of the cone, here, it looks like a trapezoid, but in reality, this is a cone. A cone is like this, you know? But without this end. This is called frustum. Frustum, ya shabab. Frustum. If you have multiple ones of a frustum, we call them frusta. Frusta, okay? This is the plural of a frustum. Now, in reality, this frustum is like this. Deep inside, there is a hole where the bolt is going through. Do you understand? Now, it turns out if I do this in a 2D, the frustum, ya shabab, is going to be like this. Didn't you agree? صح ولا لا? You know, I took the cone and then I cut the tip on the top and the top bar, and then because there is a bolt, I have this part and this part now in 2D. Good. Now, it turns out, ya shabab, that mathematically, this dimension, this one, this one, and the angle and the depth will determine the stiffness of the member, because this is where the clamping is happening. So the story goes like this. If you have everything made up from the same material, you don't have a problem. Why? Because if you want to calculate the stiffness is a function of the modulus of elasticity and other things. So if everything in the clamp is made from the same material, which we will show you later, it is not difficult. But if it is not the case, so let's assume that this plate is yellow, which means it is made from copper. You see? For example, and the one at the bottom, let's assume that the one at the bottom, I am running out of colors over here. Let me make it maybe red, okay? So this is the other one. This is the other member. Now, ya shabab, I'm gonna tell you this. Mathematically, the math for this problem was established for one single frustum. الفرستم هذا راح يكون له thickness, راح يكون له diameter, and we have the inside. So this is the diameter of the top part, we will call it capital D. The diameter of the bolt, we will call it small d. And the thickness of the frustum, we will call it T. Now, everything in here is made up from the same material. طيب, لو أنا جيت يا شباب على سبيل المثال, I want you to focus with me. لو أنا جيت وقلت لك أنا باجي وباخذ النقطة هذه إلى هنا, and then هذه like this and like this. Now, I have one black frustum. صح ولا لا؟ I have a black frustum now. I'm gonna draw it right here. Okay, this black frustum inside over here, this is the diameter D. However, ya shabab, inside the black frustum, I have a little washer, and then I have a yellow part of the yellow material, and I have a red material. تورطنا. What is the modulus of elasticity of this frustum? We have 3. Maybe, if you are lucky, the washer will have the same modulus of elasticity like the yellow or the red. But for now, we have a gray, we have yellow, we have red. So this is the problem. You cannot deal with one frustum made up from different material. فشنو الحل يا شباب? Anybody would make a suggestion?
دكتور ناخذ اثنين مودلس
What?
ناخذ اثنين ناخذ 2 مودلس اوف الاستيفيتي تكون في دواشر حق الغرفات.
Yes. If I heard you well يا علي, قول لي انت مو مضطر انك تجي وتعمل. من هو قال لك انه لازم الفرستم يكون الى هنا؟ Nobody told you to do so. So what do? You take a little frustum here. That's frustum number 1 for the washer. You take a little frustum for the yellow, and you take another frustum for the red. طيب هل خلصنا؟ لا ما خلصنا. So this is frustum number 1. This is frustum number 2. This is frustum number 3. هل انتهينا؟ لا. باقي اللي في الأسفل يا شباب. Look at it. This big one. So the blue one now has what? Has one little washer and the remaining is red. So using the same analogy, ya shabab, I am going to split this into a frustum, which is like this. انتبهوا هذا مقلوب. It's flipped. Okay? The big diameter, which is the smaller diameter of the frustum, is here. This is D now. And then this is a frustum number 4. And then in here, I have a frustum number 5. Do you understand? Now, each of these frustum has a thickness. This is thickness 1. This is thickness 2. This is thickness 3. Each one of them has a small diameter. This is D capital 1. This one is D capital 2. And this one is D capital 3. This one is D capital 5. And this one is D capital, 4. Each one of them now, I can analyze it by itself. Now, unfortunately, you might be happy now that, whoa, the problem is solved. But it's solved, actually. It's true. But you need to wait for the next surprise. So basically, if you have this problem, you can deal with it. But you will have to solve it maybe in 1 hour, depending on how fast you are. Of course, in the beginning, maybe when you get trained, you will solve it maybe in 15 minutes. You can easily make a mistake. You have to be very careful. Why is that? Well, it turns out, ya shabab, mathematically, that the equation of the frustum is like this. I'm not going to go in the detail. This is K. K for one single frustum. This is this frustum. Look, the small diameter is D. The angle here, which is called, I think, the apex angle, is alpha. The thickness is there. And this is the small diameter of the hole which is going inside. The diameter there, we don't care about it. Don't worry about it. We always look at the smaller diameter of the frustum. Now, if we know that this frustum is occupying one single material, then this is the modulus of elasticity. This is pi. This is the small d. This is tan alpha. Then we have 2 multiplied by ln. And then we have 2 multiplied by 2. T, which is the thickness is there, and then tan alpha, and then capital D, and then small d, and so on and so on. Now, since it was experimentally verified that an assumption of an angle alpha is 30 is very reasonable, we can substitute tan 30. And if we do so, the equation will get a little bit more friendly because we have K here. And again, look, we got rid of tan alpha over there. So we got a constant 0.5774 multiplied by pi, multiplied by E, multiplied by D. Down, also, we got rid of tan alpha. Now, this is now the equation of the frustum. Now, what happened is this. If you, ya shabab, if you are lucky and the entire member is made up of from everything, the washer, the yellow one, this one, all of everything, and the other washer are all made from the same material. كله steel. Okay? If you are that lucky, then using the symmetry, okay, and assume, you will have now the thickness will become L, the entire grip from the beginning to the end. And knowing that the diameter of the washer, I'm missing something here. Usual, just keep it. Diameter of the washer is being added over here. Then what will happen? You will have this equation. So this equation is giving you Km, the entire stiffness of the member. You don't need to make frustum number 1, number 2, number 3, 4, 5. You don't need to. This is the luckiest day in your life. If you get a problem where everything is made up from the same material, you don't need to worry. You do just to plug the numbers. Just to plug the numbers. Of course, in here, I am putting the equation with alpha as an unknown, but you can easily assume it to be 30. Okay? The rest is the length of the grip, the diameter of the washer, and the diameter of the bolt, and that's it. Okay? Now, what happened if you make few assumptions over here? The few assumption is that usually the diameter of the washer is about 50 times greater than the hexagonal nut of the bolt and the nut. So you can easily assume that the diameter of the washer is equal to 1.5 the diameter of the bolt, which is D. So if you substitute that and substitute that the angle is alpha equals to 30, you will have the shortest equation possible for all of this problem. This problem, look at it, this equation, which has E, the modulus of elasticity, D, the diameter of the bolt, and L, the length of the grip, or everything from head to from the face of the bolt and the face of the nut, and that's it. You put these numbers inside this equation, you get the stiffness of the entire member, But this is why I wrote this as a note for you. This equation includes everything, okay? Everything in between. Now, there is another relation which is in the book, okay? Which is, has been developed for few certain conditions. And it is saying that Km over ED, the modulus of elasticity by the diameter of the bolt, equals to A. This one is the exponential, ya shabab. It's like A E to the power BD over L. So this is the equation, Km over ED. Now, what is E? Is the modulus of elasticity. D is the bolt diameter. Here is the bolt diameter. Here is the length of the grip. Again, this equation is for a material which is entirely a joint, which is entirely made from the same material. The question is, what is A and what is B? A and B are constant, and you can find them in this table. So it has been made for certain limited cases. And we will see an example on how to use this equation. But we will be mostly focused on how to calculate it for any case. These one are very special cases. So what are we going to do? This is what are we going to do, ya shabab. We need to read this example together and start solving it. Now, it says, showing in the figure, I'm going to show you the figure. This is the figure. The figure is coming. Okay, so this is the figure. We're going to now go to the question. All right. That we have two plates, okay, clamped by washer-faced, okay? Look, washer-faced 1/2 inches, 20 UNF multiplied by 1.5 inches SAE grade 5. Do you know that the entire thing I wrote from here to here is actually the name of the bolt? This is like a father, a grandfather, and grandfather, and then a family name. This is the entire name of the bolt. But don't worry, we will teach you what does this mean, okay? Okay, don't worry about it. Now, it says we are grade 5 bolt each. So there are 5 bolts. This is an arrangement with 5 bolts. All right. And it says that each one of them with a standard, you know, we are using a standard 1/2 in steel plain washer. Again, this is the name of the washer. Okay, and again, why do we need the name of the washer? In order to know its thickness. That's it. It's a steel. We know that it's a steel. And the bolt also, we will know that it's also steel. It says here, determine the member spring rate, which is the K. It's like we call it spring rate, but it's just the stiffness Km. Okay. If the top plate is steel and the bottom plate is a gray cast iron, خلاص, you have no choice here. The one on the top is a steel. The one on the bottom is a gray cast iron. So using one single equation doesn't work anymore. And then it says, using the method of the conical thruster, okay, determine the member spring rate, Km, if they are both made from the same steel. Both of them are made from the same steel. طبعا هناك cast iron, gray cast iron, has a different modulus of elasticity than steel. This is where we have a problem. And then the question says, determine what happens if this is all entirely made from the same material. Then it says, use the equation, which I told you, A exponential to the power B D over L, to determine the spring rate if the plates are made from steel and compare the result. Then determine the bolt spring rate, which is KB. طبعا المثال هذا يا شباب is a very typical exam problem. You understand? At least in the old days when you used to come here, we have 2.5 hours exam. We told the student, this is the beginning. Find Km, find KB, and then we tell them, go and find the factor of safety. Do you understand? So this is the story. Now here we don't know, we didn't teach you yet how to find the factor of safety. And now we just want to teach you how to find Km. KB is not very difficult, but Km is the lengthy one, especially when you have two different materials. Okay, so let me tell you what do we do. Here in the solution, it says go to table A32. A32, if you remember, we talked about it before, and we told you that this is the table which will provide you with the, I think, if I am not mistaken, A32. Okay. Just wait a second. Unfortunately, I didn't put it. I was supposed to put the A32, but I didn't do it. I was planning to show it to you. So you go to table A32, and basically you will find 1/2n washer. That table is for washers. And from there, you will get that the thickness of the washer is equal to 0.095 inches. That's all what you need to know. Why? Because the modulus of elasticity for the washer is the same. It's the steel. The bolt, by the way, if you don't know, all of the screw tables that are available in this textbook are for steel bolt. يعني لا تقول لي هذا aluminum, whatever. We don't deal with them, at least in this book. So here, we knew what is the thickness of the washer. Now, how is this going to help us? Well, let me show you. This is the diagram. Okay, I'm sorry, I shouldn't have moved this. Okay, so this is the figure that was provided to us. The figure that was provided to us is this one. This is what you are going to have in the exam. And this is what you are going to draw in the solution. So in the exam, we've been given this. As you see, you have the head here, down. This is the nut. We know that the face here is where the clamp is going to start. And then here, look, the washer is bigger than the head, which is very, I mean, that's why we put it there. And what happened is this. You see the head is there and the washer is there. So we know that clamping will start from the face to face. So what are we going to do? We'll see that from table A32, we determine that the washer has a thickness of 0.095. Okay? Then we were told in the problem that the thickness of the first plate, which is steel, is what? 1/2 inch. And this one is 3/4. That's a quarter, 3/4 of an inch. So this one is a gray cast iron. And it was intentionally here made by 2 different colors, just to remind you that be careful, this one is different material than the other one. Now what happened is this. If we go to table A29, all right, if we go to table A29, we will see that, look, in the question, we were told, let me show you over here. We were told that the bolt is, look, it says 1 inch, okay? And then we have 20 UNF, and then we have a cross multiplication sign, 1 and then 1/2 inch, and then we have SAE grade 5. I intentionally split these into 3 parts. I mean, 1, 2, 3, 4 parts. This one, this one, this one, and this one. The first part of these is this guy. The first one, whenever they tell you a screw, which is 1/2 inch, what does 1/2 inch mean? It's diameter. So this one is a small d. 20 UNF. UNF is for fine threading, and 20 will tell you what is the number of thread per inch. If you know this, you will also go to table A2, and for 1/2 inch UNF, you will know what is the threaded area, which will be used later for KB. Do you understand? And then this is going to be the length of the bolt, which is capital L. This is going to teach us, another table will teach us grade 5 SAE is a steel. And later we will know that SAE grade 5 has a yield strength, has an ultimate strength, just like 1050, just like 1030. So this one will tell you the strength, material property of the bolt. This is the length. This one is the threading, and this one is the diameter. Do you understand? So what are we going to do? If we go to table A29 and look for a hexagonal nut, and for size 1/2 inch, which is 1/2 an inch, how much is going to be the head? يعني إذا عندك bolt diameter حقه 1.5 inch, how much is this? How much? Why? Why this is very important? Yes, يا علي.
ما think دكتور شلون اعرف الهيد من الانش نفسه؟ لما في 3 ارقام هنا كيف اعرف الهيد اذا حددنا الانش؟ لان عندنا الان هنا 3 ارقام، الدبليو والاتش والار.
Can you علي bring the mic closer to you?
اكتب لك الدكتور في الشات افضل.
Okay. So what happened is We need this width. Why? Do you remember the point over here? This one and this one, where the pressure is going to start. These are all determined by the width of the nut and the head. طبعا خلاص إذا عرفنا the width of the head or the nut is the same. They are the same. They are not different. Do you understand? I think I'm gonna end it. When we go to 1/2 inch hexagonal nut for 1/2 inch diameter, the width is 3/4. Okay, so this width is equal to 3/4 inches, which is 0.75. Do you understand? Now I need to take the attendance, ya shabab. Continue inshallah next class. I'm going to ask you to turn on your webcam, ya shabab. Let's take the attendance. You have only 1 minute. Over here. No, let me put it over here.
Yes, Faisal Abu Shah.
Faisal? Okay, حياك الله. Now, who's next? You can leave, okay, right away if you want. Yusuf? Yusuf? Where are you? I don't see you, Yusuf. Hamid?
Yes, Hamid.
Hamid, sorry, Hamid. Ali Al-Qahtani, I think I saw him. Ali? Where are you, Ali? No, I'm mistaken. So, Yusuf? Yusuf?
Yes, here.
Okay.
موجود.
ماجد العباد? Majid, you are here. Can you say yes? Hussein, Ali?
Yes, I am here.
Yes. Yes, doctor.
Muhammad?
Yes.
Hassan?
Yes.
Mubarak? Dosari? Mubarak? Ahmed? Ahmed is not here. Ali is here. Mu'jib is here. Sultan Al-Harbi?
Yes, doctor.
Abdullah? Hijab?
Yes.
Sultan?
Yes.
Abdurrahman?
Yes.
Abdullah, are you here? Ya Hijab?
Yes, yes.
Khalid Al-Ataybi?
موجود دكتور موجود.
العوفي؟
Yes.
فارس قحطاني؟
دكتور.
Yes, doctor.
ثابت؟ علي
دكتور.
رمضان. Yes, who's talking?
عبد الله الحجاب.
Yeah, I signed you in.
Okay.
علي رمضان
موجود دكتور.
is here. هاشم
موجود.
ماجد
Yes, doctor.
محمد
Yes, doctor.
أحمد السلطان is here. مشعل وليد
Yes.
اوكي محمد بارشيد
دكتور موجود.
اوكي عبد الله سفياني
Yes.
is here and Ahmed.
Yes.
Okay, anyone else يا شباب؟
أبو تاكي يوسف دكتور.
قحطاني علي is he here؟ مبارك أحمد غزالي ثابت؟ مشعل؟
يس دكتور.
where يا مشعل؟
موجود دكتور.
اوكي ثانك يو سو ماتش يا شباب.